Okay, so we're going to be graphing the quadratics here that we were given, but before we can do that, we actually need to fix the equation so that it's equal to 0 on the right side in this case. And in order to do that, I have to understand that for each part here, this plus 2x, I'm going to subtract it from this negative 9x. And then this plus 3, I'm going to subtract it from this positive 13. And this is going to help us fix the equation. So we're going to have x squared, and then negative 2 minus 9 is going to be negative 11. You keep your x. And then 13 minus 3, that's going to be positive 10. And now it's equal to 0. And what we're going to do next is then go ahead and graph the equation, and then we'll sketch it out. So this is x squared minus 11x plus 10. And when I sketch it out, I'm going to have to move my graph here in Desmos. I want to make sure that I can see all four. In this case, I have two solutions. I have a y-intercept and I have the vertex. I just want to make sure that I can see all those points. And so I'm going to go ahead and just do a quick sketch of the graph here on mine. It's not going to be perfect, but the idea is we just show generally where those locations are at on the graph. We notice here that the two solutions are going to be on the positive side of the x. The vertex is in quadrant 4, and the y-intercept is on the positive side of the y-axis. Now, the nice thing about this, from the equation, the positive 10, this number right there, that is your y-intercept, because this is in standard form, so your y-intercept is the last component, your constant value. So starting from there, I would have the y-intercept, and I look here on the graph, it's at 0, 10. So the y-intercept is at 0, 10. Moving from the y-intercept, I move on to the x-intercepts. I have two of those. I have 1, 0 and 10, 0. Okay, and then the solutions are x equals 1 and x equals 10. So they're literally just the x values of the x-intercepts. Now, the nice thing also, since you know what the solutions are, or you know what the x-intercepts are, you can actually write the factors of this quadratic without having gone through all the factoring method. Since your a is 1, you won't have to worry about dividing anything out either. So what you do is you take the 1 and the 10, and you're going to change the sign of them. So instead of plus 1, it's going to be x minus 1, and then it'd be x minus 10. And this is the factored form of this quadratic here, and I'll show you that on the screen. So if I went x minus 1, you'll see that it goes through one of the solution points, so that's a good confirmation that you did it correctly. And then if I did x minus 10, you'll see it goes through the other solution points, so those are correct. If I had put plus 10, you'll see that it doesn't go through one of the solution points. If I put plus 1, you'll see that it's not going through the solution point either. So this is why you have to change the sign, because you are trying to make it go to 0. By typing in both of the factors, by multiplying them, you'll see that you get the exact same picture. So this is a good way to confirm that you have actually factored your quadratic correctly. Uh, the other way to confirm it also, again, is to just check each factor individually, make sure it goes through the solution point on the graph. So we do have the correct factored form of this quadratic. Okay, now from the x-intercept and the solutions, we're going to move on to the vertex. The vertex is, let's see where we're at. Okay, you will have some ugly vertices and some ugly solutions and all of that. Do not be afraid of that part. The vertex in this case is at 5.5 and negative 20.25. That's its address location. The axis of symmetry, you're going to pull that directly from the x value of the vertex, so it's x equals 5.5. When you look at this graph, it is opening up. So this one opens up. And because it's opening up, that actually means that I'm going to have a range of y is greater than or equal to. Since it's opening up, this is called a minimum. And the minimum is y equals negative 20.25. And then the range itself is the same value as your minimum, so y is greater than or equal to negative 20.25. And because we are now dealing with a function, that just means that x, the domain is going to be x, is all real numbers.